Another shortcut for derivatives that gets used very frequently is referred to as the power rule. The power rule is, in general, how you take the derivative of x raised to a power. What I'm going to do is demonstrate what this derivative is from our information from previous videos. For example, if we had f of x is equal to x raised to the 0 power, that would be a constant. In that case, f prime of x would be equal to 0. In our last video, we considered the identity function x raised to the first power. We got that that derivative was equal to 1. We've shown several times that the derivative of x squared is going to be equal to 2x. This comes from the limit as h approaches 0 of x plus h quantity squared minus x squared all over h. When you expand the x plus h quantity squared, you're going to wind up with an x squared plus 2x plus, 2xh plus h squared. What happens is the powers of x will cancel. Everything else will have its h's reduced by 1 from dividing by h, and you'll be left with just whatever term had a singular h attached to it. The reason that I bring this up is because we're going to start seeing a pattern. If f of x is equal to x cubed, then f prime of x is going to be the limit as h approaches 0 of x plus h quantity cubed minus x cubed all over h. Like we observed for x squared, if you expand x plus h quantity cubed, you'll get x cubed plus 3x squared h plus 3xh squared plus h cubed. You'll still have a minus x cubed, and you'll still have an h. This is where we're going to start seeing a pattern. Just like what happened up here, what will happen is the x cubeds will cancel out. Everything else that has an h left over is going to lose an h when we cancel it with the h in the denominator. Anything that still has an h left over is going to go to 0. This means that the only thing left over is going to be 3x squared. Now, I will let you know that if you repeat this process again with x raised to the 4th power, you will wind up with 4x cubed. At this point between the coefficients and the resulting powers of x, you've probably noticed a pattern. That pattern is referred to as the power rule. You'll notice that every time I take a derivative of a power of x, two things take place. We get a coefficient that is numerically equal to whatever the power just was. Then the power of x winds up getting reduced by 1. And again, that comes from canceling out that 1h term. So, in general, the power rule looks like the following. If you start with x raised to the n power, that will be n times x raised to the n minus 1 power. Formally, this is known as the power rule. It is a derivative shortcut for how to take the derivative of powers of x. Now, we can let the powers of x be as ridiculous as we want. We could say f of x is equal to, let's go with my birth year. X is equal to 1971, or x to the power of 1971. According to the power rule, that would be f prime of x is equal to multiply by the current power, then reduce the power by 1. If you'd like, we could then repeat the power rule and make use of the constant multiple rule if you really feel like multiplying 1971 by 1970. I don't really feel like doing that. Let's do g of x this time. G of x is equal to the square root of x. Now, in its current form, it doesn't really look like a power, but a habit that we're about to pick up is anytime we're dealing with radicals, refer to them as rational exponents. Square root of x is the same as x raised to the 1/2 power. If we were to apply the power rule in this case, we multiply by the current power, that's 1/2, and reduce the power by 1. that would be 1/2 minus 1. 1/2 minus 1, if you get a common denominator, will be the negative 1/2 power. This also works for things like negative exponents. I believe we did this one in a previous video. H of x is equal to 1 over x. Expressed as a power of x, that would be x to the negative 1 power. Applying the power rule in this case, we multiply by the current power and reduce the power by 1. Negative 1 is going to have 1 subtracted from it. Negative 1 minus 1 is negative 2. This can also be re-expressed in terms of a rational expression as negative 1 over x squared.